Good evening, guys. This evening, we are going to have tutorials on risk and returns and choosing an efficient portfolio. That is what we are going to discuss. So I'll start off with reading the first question. And it says, suppose Fed Motor Stock has an expected return of 20% and a volatility of 40%. And Molson Coors has an expected return of 10% and a volatility of 30%. If the two stocks are uncorrelated, A, what is the expected return and volatility of an equally weighted portfolio of the two stocks? Okay, so let's start by writing down the information. So we have two stocks. We have Ford Motor. We have Ford. Then we have Coors Brewing. And the expected return, I'll call it R, expected return, and the volatility, So the question says the expected return of Ford is 20%, that is 0.2, and the volatility is 40%, that is 0.4. The next thing is Molson Coors also has an expected return of 10%, that is 0.1, and a volatility of 30%, that is 0.3. If these two stocks are uncorrelated, which implies that the correlation between the two, that is correlation between F and Coors is equals to 0 because they are uncorrelated. What is the expected return of a volatility and the volatility of an equally weighted portfolio of the two stocks? So first of all, they said they have what? Equal weight. That means X of Ford is equals to 0.5 or half, and X of Coors also equals to what? 0.5. So what's the formula for finding expected return? Now, expected return formula is equals to the weight of F multiplied by the return on F plus the weight of C multiplied by the return on C. So which gives you 0.5 multiplied by return, which is 0.2, plus XC, that is 0.5, multiplied by 0.1. That means you can as well, okay, so you have 0.5 times 0.2, that gives you 1/10, plus, so I would say this is 0.1, plus 0.5 times 0.1, 0.05 times 0.1, that gives you 0.05. So when you add the two, that will give you equals what? 0.15, which is the same as 15%. So this is the expected return on the portfolio. Is okay? Now the next question says, okay, so the next question says, the volatility. So what's the formula for finding volatility? The volatility of a portfolio is equals to the weight of this squared plus the volatility plus its volatility plus the weight of the second asset, which is C, all squared, plus the volatility of C plus 2x of F, x of C, multiplied by the covariance of x of F, x of C. Great. So, but we also know, because in the question we were given correlation, then I can say covariance of XF, XC is equals to the correlation between F and C multiply by the standard error of F, or the volatility of F, and then volatility of C. So let's look at the question. So in the question, they said they have equal weights, and the volatility was also given in the question, right? So I'll just say the portfolio variance is equals to, what is the weight? 1/5, 1/2, sorry, 1/2, that's 1/2. So it's 0.5 all squared, multiplied by the volatility of F, which is 0.4 all squared, plus the next one is XC, which is 0.5 all squared, multiplied by 0.3, that's the volatility all squared, plus then 0.5 multiplied by the standard error that they said, or the correlation is what? They are uncorrelated. So because they are uncorrelated, this one is 0. That means when I multiply by the volatility with 0.4 and then 0.3, right? Now, because in the question it was stated that the correlation is equal to what? They are uncorrelated, that means it's 0. So what it means is that this whole expression becomes 0. So that means I have only these ones left. So then I will say the portfolio of the variance is equals to 0.5 squared times 0.4 squared, which is 0.04 plus 0.5 squared times 0.3 squared, which is also equals to 0.0225. So when I add the two up, I have variance of the portfolio as 0.4425, and then the volatility of the portfolio is equals to the square root of 0.4425. So when I find the square root of the answer, I get 65%. Get 65%. I hope it's okay. Okay. So let's look at it again. So let's do another check. 0.05 squared, 0.5 squared times 0.4 squared is great. So it's 0.04, sorry, no 0.4, 0.04 is okay, plus 0.0225, and that gives you, so we have so that means we have 0.0625. Now when you find the square root of the answer, and that gives you, okay, 25, so 0.0625, and that gives you 25% instead. Great. So that is 25%. So what it implies is that the volatility of this portfolio, so that means mu of this portfolio and the volatility of this portfolio is equals to, or this is mu is equals to, when we did for the mu, what did we get? You can cross check again. When we did for the mean, okay, so we had the portfolio return to be 15% and the volatility at the 25%. Great. So it was 15% and the volatility as 25%. So the next follow-up question is, given your answer to part A, is investing all of your money in Melton Crook's stock an efficient of this portfolio? So let's try and write these two, then we can compare. So we have So we have that of Ford, we have Crooks, and then we have the portfolio, that the combination of the two, the portfolio, right? So let's write the mu, their return here, and the volatility here. So with respect to that of Ford, we were given what, 20%, and volatility was what, 40%. And in the case of brewing and Molson Coors Brewing, we were given 10% and 30% here. And after calculating for the portfolio, we are having 15% and this 25%. So the question is asking that, given your answers to part A, is investing all your money in this? Is in this in an efficient portfolio of these two stocks? So investing all your money. So giving your answers to part A, is investing all your money in Molson Cook stock an efficient portfolio to these two stocks? Now look at something. If you invest all your money in Crooks alone, you're having expected return of what? 10%, and a volatility of what? 30%, right? So that means at a higher risk, you are getting lower return of 10%. Meanwhile, if you invest in the portfolio, you are having what? A lower risk, 25, and having a higher what? Return, 15%, which means investing all your stock in what? In that of Molson Coors is what? It's not efficient portfolio, right? It's not efficient. Why should you invest in Crooks that is giving you what, 10% return at a risk of 30, when you could have invested in this portfolio with a risk of a return of what, 15%, which is higher than this, and at the same time at a lower risk? Is okay. Now the next question is the C part. Is investing all of your money in Ford an efficient portfolio for these two stocks? So if you invest in Ford, now if you invest in Ford, that is at this point, if you are going to invest in Ford, that will give you what? A return of 20%, but at a higher risk of 40. It's okay. But if you invest in this one, this is also going to give you a 15% at a lower risk. Now look at something. In this case, we can say it's what? It's inconclusive. Because if I'm investing in Ford alone, and that is fetching me what, 20% at a higher risk. However, when I invest in this one, that is also fetching me 15%, but also at a lower risk. So as long as the volatility here and this are not the same, I cannot conclude. So it is going to depend on the risk preference of the person. If somebody is risk loving, the person can go for this one. But if the person is risk averse, the person might also settle on this one, right? So in conclusion, what we are saying is that in the situation whereby you do not have the volatility, in this case, the volatility of this one, though this one is higher than this, but the one that is higher promises a higher returns relative to this one, is okay. So if I choose 15, if I decide to choose portfolio 15, this portfolio that is giving me 15, but at a lower risk, is okay. So once I go for this is also giving me 20, but I had at a higher risk. So in this case, I will say it is inconclusive. It's okay. So let's look at the next question. This is 22. Let's look at the next question. So I hope this part is okay. So we are looking at the next question. Suppose Intel stock has an expected return of 26%. So let's write it again. Suppose Intel has an expected return. So let me write Intel here. Suppose Intel has an expected return of 26%, R is equal to 26%, and a volatility of 50%. Yeah. And the next question is why Coca-Cola has an expected return. So Coca-Cola has an expected return of, why Coca-Cola had an expected return of 6%. and a volatility of 25%. If these two stocks were perfectly negatively correlated, so that is the correlation between ITER and that of Cook is equal to what? -1. That is, they are perfectly negatively related. Calculate the portfolio weight that remove all risk. So the question is, calculate the portfolio weight that remove all risk. It's okay. Now look at something. In this case, remove the, so the risk in this case represents what? The volatility or the variance of the portfolio. It represents the variance of the portfolio, right? That removes all risk. Great. So first of all, let us write the formula for finding the portfolio. Is it okay? So we have Intel and Cook. So I will say the variance of the portfolio is equals to the weight of Intel squared multiplied by the variance of Intel plus the weight of Cook multiplied by the variance of Cook plus multiplied by the variance of Cook. Sorry, 1 minute. Multiplied by the variance of Cook. Oh, who is spring? Okay, guys, sorry. So yeah. Okay, great. So yeah, n plus 2x the weight of Intel plus that of Cook and the correlation of Cook and Intel multiplied by the volatility of Cook and then volatility of Intel. This is what we have. So this is the portfolio variance. It's okay. Yeah, great. And they are saying that we should find a way that will ensure that what we've been able to remove all risk. That means if we remove all risk, it means portfolio variance is what equals to 0. Is okay. Now, and also don't forget, we always have to get our weight, and the weight is equals to what? X, the share of Intel plus the share of Cook should be equals to 1. Is okay. Now from this, then I can see X. Let's say I can see X I Intel is equals to 1 minus XC. Mind you, with this, you are not being asked to find the minimum variance that you have to differentiate. No. They are just saying that find the weight that will ensure that the portfolio variance is equal to what? 0. They didn't say the minimum. So great. Then if that's the case, I can say that, okay, X1. So now we are saying that the X1, Xi equals to what? 1 minus X. So I can say, look, I want to replace everything in this. Is okay. I want to replace everything in the portfolio variance formula. So let's write the formula again. So I will say the portfolio variance, this is equals to, now I have X1 squared, but in the question we were given the volatility, right? So they said in the question, they said Intel has a volatility of what? A volatility of 0.5. So that means instead of I square write 0.5, they said it has a volatility of 0.5. Yeah. So instead of writing I squared, I'm just going to write the volatility of what? This one. So then this is the variance. So it becomes 0.5 squared. And instead of xi here, we now know xi equals to this. So it becomes 1 minus xt all squared plus what is the volatility of also the Cook. And in the question it was given us Coca-Cola has 25. So it becomes 0.25 squared multiplied by xc. It's okay. Plus we have 2. We are replacing this xi. You say it's written as 1 minus xc multiplied by xc. Is okay. And then correlation is what? -1. So times -1. And the volatility of this one is 0.5 multiplied by 0.5. And that of 0.25. Yeah, the 0.25. Great. Okay. So let's clear the top here. I don't want to leave this page. Don't want to leave this page. Don't want to leave this page. Yeah, great. So let's multiply the 2 times. So I'm going to multiply this part. Yeah. So I'm going to have 2 times -1 times 0.5 times 0.25. And that gives me -0.25. So that means I have this expression equals what? -0.25 is okay, into brackets 1 minus xc multiplied by xc is okay. So let's come to this expression 2. Now this expression is going to give you 0.5 squared. That gives you 0.25. So that will give you 0.25. 0.25. 1 minus xc all squared. 1 minus xc all squared plus, and you have this as 0.25 squared, 0.25 squared, which is 0.06, 0.0625 xc, 0.0265 xc. So xc squared yeah, great. So I'm going to clear the down part here too so that I can write. Okay, so from here we can expand. So by the way, at the end of the day, we are equating everything to equals 0 because we said when everything here should be equals to 0. It's okay. So I'm going to have 0.25 into brackets. This is 1 minus s squared. So it's going to be 1 minus 2xc plus xc squared plus xc squared plus 0.0625 xc squared. And this one is also going to give me minus 0.25. Then I'm going to give you xc minus xc squared. Great. And you create everything equals to 0. So from here, when I multiply this by this, I'm going to have my 0.25. This is going to give me 0.25. When I multiply this by this, 0.25 times 2, that will give me minus 0.5. XC minus 0.5 XC. Great. And when I multiply this by this, it's going to give me plus 0.25 XC squared. And this one is also the same thing, plus 0.0625 XC squared. Then multiply this by this, that's going to be minus 0.25 XC minus 0.025 XC squared. So this is going to be plus because there's a minus here. It's going. So let's look at it again. Yeah, so because there's a minus here, yeah, it's going to give you negative. So that means we are going to have positive. Minus times minus gives you positive. Is that okay? Yeah. Great. So let me clear this part again. Now from here, you equate everything to 0. So what you have to do here is just your normal simplification. So let's look at, we have 0.25 here squared here. So you can group the like terms and say this is the same as 0.25 plus 0.25 plus 0.0625. That gives you 5 points. So that will have 5.6, sorry, 0.5. That will give me 0.5625 XC squared. So I'm done with this and this one, and the next one is this. So when I add this one also up, I'm going to have minus 0.5 minus 0.25. So I have minus 0.75. 0.5 plus 0.25. That gives you minus 0.75 XC plus 0.25 equals to 0. So this becomes a quadratic equation. So you can solve using calculator. So when you solve using calculator, you have it as, okay, so 0.5625 minus 0.75, 0.25. So that means when you have x, when you solve this quadratic equation, you have xc is equals to 2 over 3, and that of then the xi becomes 1 equals to 1 minus 2 over 3, which is equals to 1 over 3. So this is the weight that when they choose, they are going to have a portfolio, the risk to be 0. So this is the weights. So if you want to have a rate of risk equal to 0, then you're supposed to invest 2/3 of your money in Coca-Cola and then 1/3 of it in Intel. When you do this, that means the risk of the portfolio or the portfolio variance will be equal to 0. So if you want to cross-check, you can fix in this value and this value into the portfolio formula, and you have it to be equal to 0. So let's look on to the next question. The next question. Okay, the next question. Okay. So the next question is, coming clear. Okay, so in the next question, we have a hedge fund has created a portfolio using just 2 stocks. It has shorted 35,000 worth of oracles. So we have 2 stocks. We have oracles. We have oracle, and we have the next one, and we have Intel. Great. So the amount invested in each of them. So they said it has shorted 35 million worth of oracle. So once you hear shorted, it means it's negative, either short sale or long sale. So that becomes minus 35 million. So I'm writing 35, reducing it to 3 zeros. It has shorted 35 million worth of oracles and has purchased 85 million worth of Intel. And then this is minus, and Intel is equals to this. Great. So that means when I add up the two, I'm going to have 85 plus 35, which will give me 50. Yeah, so 85 plus minus 35 plus 85 will give you 50. So that means this one is 50. Great. So once we know it's 50, then we can find our weight. So the weight for each, this can minus 35 divided by 50, and that gives you minus 0.7. And this gives you 85 divided by 50, that gives you 1.7. So when you sum up the weight, is equals 1. So the next question is the correlation between Oracle and Intel is 0.65, and the following returns have been given: Intel expected return and the volatility. So this one is 12%, this one is 14.5, this one is 45%, and this one is 40%. And the correlation has been given us 0.65. So the first question is, what is the expected return of the hedge fund? So when you've been asked to find expected return is equals to X of Oracle multiplied by the return on Oracle plus X on Intel multiplied by return on Intel. And that is going to give you minus 0.7 multiplied by 12% plus 1.7 multiplied by 14.5, and that gives you, so minus 0.7 into bracket 12 plus 1.7 into bracket 14.5, that gives you 16.25%. So you have 16.25%. So this becomes the expected return, 16.25%. The next question is find what is the standard deviation. So what is the standard deviation? So looking for, first you have to look for the variance of the portfolio. So the variance of the portfolio now becomes X on Oracle squared, variance on Oracle, plus X on Intel squared, multiplied by return variance of Intel, plus 2X Intel, this is Oracle, then correlation multiplied by volatility of Oracle and the volatility of Intel. Great. So let's look at it from the question. So we know that X of weight of Oracle was what? Negative 0.7. So you can negative 0.7 all squared multiplied by the volatility, which is 0.45 all squared plus that of 1.7 for Intel multiplied by the volatility with 0.4 squared plus 2 minus 0.7 and then 1.7 And the correlation is what? 0.65. And then multiply by the volatility, which is 0.45 and 0.4. So when you solve this, you are going to get, I think I can code it from my end. When you solve this, you are going to get the volatility is equals to, when you add up everything from here, you are going to get volatility to be equal to 0.28314. So when you find the square roots of this, that will give you the volatility. This is a variance. So when you find the square roots, 0.28314, which gives you 53.21. It's okay. So this represents the volatility of the portfolio. So the next question is, so this for the B part. The next question is, suppose the correlation between Intel and Oracle has increased. Now the correlation was given us 0.65. Now the question is, suppose it has increased. Suppose it is increased. When it is increased, suppose the correlation has increased, but nothing else changes. Will the portfolio be more or less risky with this change? Now look at something. If it was 0.65, let's say it has increased to 0.8. What it means is that this one has increased, right? Now, once this side is increased, it means, but this expression here, because this whole expression is going to be negative, because there's a negative here, it means it is going to cause the portfolio variance to what? 4. It is going to cause it to 4. So that means it becomes less risky. If the risk is falling, that means it becomes less risky. Great. So let's look at the next question. Let's look at the next question. Let me check the time. Have I spent? Let me look at. So let's look at the last question. Then we close for the day. Now you have 10,000 to invest. You have 10,000 to invest. Okay, now so let's look at the C. Let's look at this one rather. I think this one will be okay. Suppose the target stock has an expected return of, suppose a target stock has an expected return of 20% and a volatility of 40%. Here, this stock has an expected return. So let's write them. Let's write them. And so target stock. So this is target. Suppose target stock has expected return of R, 20%, and a volatility of 40%, and a volatility of 40%. So this is the volatility. And here C stock has an expected return of 12%. Here C. Here C has an expected return of 12% and a volatility of 30%. And a volatility of 30%. And these stocks are uncorrelated. So if they are uncorrelated, then correlation equals what? 0. What is the expected return and volatility of an equal weight portfolio of these two stocks? So when you say equal weight, that means weight of target equals to weight of H equals to 0.5. Great. So once, then I can write my expected return on the portfolio as what? Half multiplied by 20 plus half multiplied by 12, and that gives you 16. So 20 plus 12 divided by 2 is 16. Yeah, that will give you 16%. Great. So the next question is and the volatility. So once we know this, let's calculate for the volatility too. So we are looking for the volatility. Now the volatility becomes half squared multiplied by, what is the volatility? 0.4 squared plus half squared multiplied by, the next one is 0.3 squared plus 2 covariance of that. In the question, it was stated that they are uncorrelated. So it comes 2x1, x2, covariance of 1 and 2. But because they are saying that they're uncorrelated, that means correlation equals 0. So every expression here becomes 0, right? So then the variance on the portfolio becomes 0.5 squared times 0.4, 0.5 squared times 0.4 squared, which is 0.04 plus 0.5 squared times 0.3 squared, which is also 0.0225. So plus 0.04, the root of answer, that gives you, so it means volatility is equals to 25%. Great. So the follow-up question is this: consider a new stock with an expected return 16% and a volatility of 30%. Suppose this new stock is uncorrelated with target and hearsay. Let's look at this new stock. So we have a new stock. So this one, okay, so let's look at the portfolio. This portfolio is giving us what? The mean of the portfolio. We have 16%, and then we are having what? The variance, volatility of this portfolio as 25%. Now let's look at this new. Consider a new stock with expected return. So let's look at the return of this new stock, which is what? 16%. Consider a new stock with 16% and a volatility of 30%, and a volatility of 30%, and a volatility. Suppose this new stock is uncorrelated with target and hearsay. Is holding this new stock alone attractive compared to holding the portfolio in A? So this is the portfolio in A. That is giving us what? Expected return of 16% and volatility of 25%. And here comes in a new stock that is giving us what? The same 16%, but at a higher risk, which implies that this is not better than our portfolio, because this portfolio is giving us what? The same return, but at a lower risk. So why should we go in for something that is giving us the same return, but at higher risk? So it means holding this stock alone is attractive. No, it's not attractive. It's okay. Can you improve on your portfolio in A? Can you improve on your portfolio in A by adding this new stock to our portfolio? So that what they are saying is that, so in case we add our new stock, which is the new one that they have been giving to us, to our existing target and that of the next one. So here, see, will we be better off? Now, because they say that there's no correlation between this new stock and that of target and here says, what it means is that when you add up, it's still going to be 0. It's not going to make any change. So let's do that mathematically. Let's do that mathematically. Look at this. So let's say we are going to have 2, right? We are adding the third one. So it's going to be weight of the first one multiplied by the variance of the first one plus weight of the second one multiplied by the variance of the second one plus weight of the third one multiplied by the variance of the third one, okay, plus 2, okay, so plus 2 covariance of x1, x2 plus 2 covariance of x1, x3 plus 2 covariance of, okay, so sorry, plus their weight. So let's see, let me clear this. Plus 2x1, x2 covariance of 1 and 2 plus 2x1, x3 covariance of 1 and 3 plus 2x1, sorry, x2, x3 covariance of 2 and 3, right? So look at something. So in the question they say what? So I'm using the third one as what? The third variable as the new one. And they said the new one has no correlation, right? So that means this one will be 0. It has no correlation with this, and it has no correlation with this, right? So that means our new variance now becomes x1 plus x2 plus x3 plus 2x1 x2 covariance of 1 and 2. Great. So what it means is that, let's look at it. Can you improve upon your portfolio in A by adding this new stock to your portfolio? So when you add your new stock to your portfolio, we can add this. So what it means is that our variance is going to increase, right? So if we add this 1 to 8, our variance is rather going to increase, though this one is going to, so we have this variance being increased, right? Now we have to also find out, so once the variance is going to increase, can you improve upon your portfolio? Can you improve upon your portfolio by adding a new stock?